Hello and welcome back to Geometry. We are in Chapter 5, Section 1, Angles of Triangles. Quick review here, classifying triangles by their sides. You can have what we call a scalene triangle, has no congruent sides. An isosceles triangle, notice it says at least two congruent sides. And that's important because an equilateral triangle, which has three congruent sides, also has at least two congruent sides, so this could also be classified as an isosceles, just like the relation between a square and a rectangle, where a square is also a rectangle, but a rectangle isn't necessarily a square. And then we can also classify triangles by their angles. So we have an acute triangle, where every angle is an acute angle. The right triangle that has one right angle, an obtuse triangle that has one obtuse angle, or an equiangular triangle. So classified by its sides or its angles. Alright, classifying triangles by sides and angles. We want to classify the shape of the support beams in the diagram by sides and by measuring its angles. First off, we have an indicator here that these two sides are congruent. It has two congruent sides, so that is an isosceles triangle. Now we'll measure for the angles. So I'm going to put my protractor on the edge here, in the corner, and I can measure, not measure from this side up to here, see what that angle is. We're at it about, no, wasn't quite on the center, that's 55, yep, 55. Alright, measure this one over here. Given that it's isosceles, it should be the same if I've lined this up correctly. 55. Alright, so those two angles are 55. 55. I can't drive 55. Name that artist. Alright, and then here, line this up on the corner up there to measure. Not perfectly lined up. We'll see whether we can get this. Okay, and measure this. Right there. Oh, where's the middle? There it is. Okay. Yep, 70 degrees. Very nice. 70 degrees. So, every one of these is an acute angle, less than 90, so this is an acute triangle. Classifying the triangle in the coordinate plane by its sides. So, we can see that this one's obviously a lot shorter than the other two. But the other two, it's not obvious whether they are the same length or not. So we're going to use the distance formula. Remember that distance formula is the difference of the x values squared plus the difference of the y values squared and the square root of that. So we'll do this line first. The x values here are 0 and 6. So 6 minus 0 squared plus 3 minus 0 squared. And again, it doesn't matter which one I put first, the 1 or the 2. So 6 minus 0 squared is 36, plus 3 minus 0 squared is 9. Boom. So that gives me 45. Radical 45. That's about 6.7, something around there. But just to compare the sides, it's good enough in radical form. Now let's see whether the other one is the same. Here we have 6 minus negative 1, so 6 plus 1 squared plus 3 minus 2, 3 minus 2 squared, that's 7 squared plus, we can already tell it's not the same, 1 squared. That's 49, which is already more than 45, plus 1 is radical 50. So these two sides are not the same length, which makes this a scalene triangle. Scalene triangle. Now, we want to determine whether it is a right triangle. Okay, this is obviously not a right angle up here, so we need to figure out whether either one of the other two is a right angle. Okay, so let's look at this one, because to me this looks the most like it might be a right angle. And we're going to do the slopes of these. So slope, remember our super trick for slope, we take the two coordinates, -1 and, I said 1, wrote 2. -1 and 2, and 0, 0. See, what's the slope between these? Change in y is 2, change in x is, or change in y is -2, change in x is 1. So the slope here is -2 over 1. And then the others, we have 0, 0 and 6, 3. Change in y is 3. Change in x is 6. So 3 over 6. That gives me 1/2. Slope here is a half. The slope here is -2 over 1. Those are opposite inverses. Okay, so which means they are perpendicular. You could have also seen that from the graph, down 2 over 1 or up 1 over 2. Okay, so they're perpendicular. That means this is a right angle right here. And so that is a right triangle. Right triangle. All right, interior angles. This is what we've looked at mostly. They form linear pairs with exterior angles. If you extend the line of a triangle beyond its corner, then we have an exterior angle. The exterior angle together with the interior angle form a linear pair. Means they add up to 180. This is just a quick review. Theorem 5.1 states that all three angles add up to 180 degrees. You already know that. Now we're going to prove that. Sometimes to prove something, you've got to add an auxiliary line. So we're going to add a line here. We're adding a parallel line. That way we can use these kind of as a transversal. And in order to do that, I'm using the parallel postulate that says to any line through a point not on a line, there's a parallel line. So I'm drawing a parallel line, and I know that these three angles add up to 180. 4 plus 2 plus 5 add up to 180 degrees. Now, I know that 4 and 1 are congruent, so are 5 and 3, because they are alternate interior angles. And so I can say that those measures are equal, so I can substitute 4 and 1 up here, 1 for 4, 3 for 5, and that way I know that those three add up to 180 degrees. All right, exterior angle theorem. If I look at this, if we know that these add up to 180 degrees, C plus this angle is 180 degrees. C plus these two, A and B, is also 180 degrees, which tells me that these two together have to be the same as angle 1. So the measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent. So not the one that it's next to, but the two other angles. So this angle right here is equal to these two added together, because that interior angle at C obviously also adds to 180 with those two. All right, knowing that, I can now find this measure. I know that this exterior angle is equal to these two, so I can do 2x minus 5 is equal to 70 plus x. Subtract x on each side. We get x minus 5 is equal to 70. Add 5, and x equals 75. Okay, a corollary theorem is a statement that can be proved easily using the theorem. So corollary to a theorem, corollary to the triangle sum theorem, if this angle right here is 90 degrees, and we know that all of them are 180 together, then I know that that leaves another 90 for these two, right? So that means A and B in a right triangle, the other two, the acute angles, add to 90 degrees. So if I have a problem like this, the red triangle is a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. So this is a right angle, and one of those is twice the measure. So let's say this one's x, then this one is twice the measure of that one. Find the measure of each acute angle. So know that 2x plus x, because of the corollary to the triangle sum theorem, tells me that those two are 90 degrees. So then I have 3x is 90 degrees. Divide by 3 and 90, I was thinking ahead. Sorry. I already had the solution in my mind. X is 30. There we go. Easy peasy, lemon squeezy. That's all the fun we have today. Check back next time for another fun lesson.